All right, welcome back. We are doing homework for 712 today. So, first question, number 17, how much is that car? So, we have Nate and Rick. We're still talking about cars. Nate claims that cars with more horsepower are more expensive than cars with less horsepower. His reason was that 300 horsepower car was worth more than Rick's 120 horsepower small economy car. So to investigate, Nate claims that the boys looked up information about their friends' cars and they created a table. So we're asked, does this information in the table support Nate's claim that cars with more horsepower cost more? Is there a relationship between horsepower and the price of the car? So we can see that horsepower is our X's and our money is on the Y side. So when we kind of are looking at things, like when we look at the highest horsepower, that's definitely this 500, and it's $38, right? So that is the most expensive car out there. However, when I look at the second most car with the second most horsepower, I see this guy, 505, which I would expect to be pretty darn similar, right? Well, no, he's only $23,000, but still, compared to 38, not that much. I can also see like this car is more, right? Costs more than this guy, but he has like half as much horsepower. So I would say that there's not that association based on that information. Cars that cost more do not always, sometimes they do, right? Because this guy do not always have more power. And don't just write no. You need to write out the whole thing. Okay? No association, we would call that. To answer the second part. Okay? All right. So next, for part B, it says that we need to set up a graph and plot the points from our table. And so we're going to do that, and then we're going to see if we agree. So I've already set mine up. I went by fives for the thousands of dollars. This is thousands of dollars, right? Okay, so it's not just like $5. And then at the bottom here, I went by 25s, but I didn't label every 25. I only labeled every 50. So I skipped one, wrote 50, skipped one 100, skipped one 150, skipped one 200. I know it's kind of hard to read, but I went all the way up to 600 because I knew that I would need a lot for that table up there. Now we just need to go ahead and plot our points. So the car that cost, I'm not going to show you my table, I'm going to show you my graph, but you can look at your table. So for the first one, it had 500 horsepower and it cost $38,000. So I'm going to come to my 500 and come up to just below the 40, right? Kind of right in there. All right, the next one was 160 horsepower, so really close to this 150. I'm going to kind of use that as my line first, and then I'll move over once I get closer. Was 16, so just above the 15, and then remember, just come over just a tad bit off of that 150 to show because that's actually 160. All right, next one was 453. So I'm going to use 450 for my kind of line, my main line. And that one was 23,000. So I'm going to come up, find my 20, and then come up a little bit more. And then I'm going to factor in that extra $3 that he had, which is basically on the line. All right, next one was 505, so basically 500. I'm just using some estimating skills here, which is fine. And then 23, so coming up again to around that 20, coming up a little bit above that 20, somewhere in between 20 and 25. Okay. And then 228. Okay, so that's going to be, if this is 225, that's pretty close. And then coming up to 30, right? Right about there. All right, next one was 311. So I'm just going to use that 300 and then I'll move over some. And then to 26,000, so pretty close to 25. And we're just plotting these points. It's going to end up being a scatter plot. Where was I? 311. Okay. 335 is going to be on the other side of this line, I know, at 325. And then up to 15. And then remember, we have to move a little bit to the, this was 35. So this was 25. Okay. A little bit to the right. Just a little bit. And then our last one, 197, is pretty close to 200. And then up to 40. All the way up here. Okay. So there is our scatter plot. And we can see our dots are all over the board, right? There's not a nice trend that's happening. So how do we believe, or now do we believe Nate's claim? No, we don't. There's no association. No association. Right? If there was, then I would see that as the horsepower increased, so did the money. There would be a nice, like, kind of, not necessarily like straight line, but a nice correlation here, showing me that that was the case. It isn't, so we're going to say no association. All right, flipping onto the back. Here we go. We have some more scatter plots to look at. It says to look at the scatter plots and use your experience to decide which statement best fits each scatter plot. So we're just kind of matching, okay? So we have the first part for A. It says a city's average daytime temperature in January and its latitude. Recall that the equator is at 0 degrees latitude and the poles are at 90, okay? So which one would best match with that? Well, I know that as I get closer to the equator, right, I would expect that it should be warmer. Okay, so as I'm getting closer, it's getting warmer. That's why this first one actually matches up really nicely with A, right? Because we would expect that those temperatures would rise. So somehow you can write next to it, you can draw arrows. This one would be A, okay? All right, next up. Weight of a car and its speed in a traffic jam on the freeway. Okay, so if there's a traffic jam, does the weight of the car have any impact on it whatsoever? No, right? It's going to stay the same regardless of how heavy the car is. So that's why it's definitely not this one, right? Now, does the speed change at all? No, right? Because everyone is staying the same depending on how, like, the weight doesn't impact that at all. So we can see that that one would actually match up nicely right here because the speed stays the same. The weight, is the only thing that's impacted. All right, next up, the number of pets a student has at home and his or her grades. I mean, I had friends at school that did really well and had pets. I had friends at school that didn't do all that great and had pets. So I know that there's not any sort of correlation, right? There's not anything that pets would have to do with grades necessarily. So that would be this no relation one right here. You just say no relation. That would be C. Okay. And, I guess we didn't really do our little sentence here, but I'll just write it off to the side here. We said that as latitudes increases, the temperature would drop. Or you could say it the other way around. You could say that, like, as the latitude line decreases, the temp goes up. It means the same thing. And then for this one, right, all cars, regardless of the weight, go the same speed. That doesn't have any impact. Okay, that means that hopefully this one matches up with this guy. Oh, and this is B. Okay. The cost of a person's home and the value of his or her car. Okay. So for this one, if someone costs a person's house, then the value of the car would be decreasing, right? Because people may have more expensive houses. They might tend to spend more money on their cars. Okay, so D. Wherever you have some room, you can write this. They spend more on cars. Okay, great. There we go. So next, we need to match the system of equations with the column at the right. So again, we need to get these into y equals mx plus b form, and then we can solve. Okay, so like for this one, if we have 6x minus y equals 4, I know I need to subtract 6x on both sides, which leaves me with negative y equals negative 6x plus 4. Ooh, you can't see that. How about there? Okay. Then we need to divide, right? Because there's that negative y, so we need to get rid of that. Y equals 6, right? Negative divided by negative is positive. 6x minus 4. Okay. So this guy right here goes with that equation. And then so much, not much room. Okay, 3x plus y equals 5. Again, getting our y by itself, so subtracting those 3 x's from either side. Just like that. Okay, and then this guy goes over here with him. Okay, now I can put them equal to each other, right, by dropping off the y's. So we have 6x minus 4 equals negative 3x plus 5. And then we're going to solve. So I'm going to add 3x on both sides. Gives me 9x minus 4 equals 5. Adding 4, right, to get rid of it over here and put it on this side. So 9x equals 9. We divide by that variable out front, which is 9. X equals 9 divided by 9 is 1. So far, I'm guessing it's probably this guy, but we got to check, right? Squiggle line here. We have to plug this back in to our equation for x. So 6 times 1 minus 4 equals, hopefully, negative 3 times 1 plus 5. We know 6 times 1 is 6 minus 4. Negative 3 times 1 is negative 3 plus 5. 6 minus 4 gives us 2. Negative 3 plus 5 gives us 2 also. So that means that y equals 2, which is, hey, look at that. Matches up beautifully. All right, so we can match those two, right? So far, so good? All righty. Next up. Okay, so this guy is actually already in that nice substitution method. So I'll show you how to do that and remind you of what that looks like. Remember, I'm going to take this equation, this part right here, and I'm going to plug it in for my x. Okay, you'll do a lot more of this next year in high school, but it's kind of a nice method. Then we doesn't always have to go into y equals form, which can sometimes cause like decimals and fractions, so it's a little bit nicer. All right, so I'm going to rewrite this equation, and instead of x, I'm just going to drop the x here and put in my y plus 4. Some equations are like set up nicely to do that, like this one is. Okay, so then we're going to solve for y. So first I'm going to distribute, right? 2 times y is 2y. 2 times 4 is 8, so plus 8 equals negative 12. Okay, there we go. I'm going to combine my terms, right? So I have 5y here plus 8 equals negative 12. Subtract 8 on both sides. 5y equals negative 20. I'm going to go ahead and divide by 5. And y equals negative 4, right? Which, look at that, is matching up right here. So how would I check that? How would I find out x? Well, I can plug it back into this equation. And guess what I'm going to plug in for y? I'm going to plug in, sorry, you haven't been able to see that, negative 4 is going to be plugged in for my y. So, and then I can just solve. So here's what that would look like. That would look like x equals, y was negative 4 plus 4, which equals 0. Look at that. Matches up. So we know that b goes along with number 1. Okay. And then we can do the same thing here. I can even plug in this. If I am solved for one variable, I can plug this stuff in for the y and I can solve. I'll show you what I mean. kind of learning on the fly here. All right, you're learning as you go. All right, so 5x minus 2 times, now I can take this part of my equation and plug it in for y because it's telling me y equals that. So 2x plus 1 equals 1. And then we're just going to, again, distribute like we normally would. So the 5x is outside of the parentheses. We just rewrite him. Negative 2 times 2x is negative 4x. Negative 2 times 1 is negative 2 equals 1. Combine our like terms. We have some x's we can combine. So we just have x minus 2 equals 1. Add 2 on either side, right, to get rid of those so that we can just have the x by itself. And x equals 3, which, look at that, it's matching up so far. All right, so we're going to then take that. Sorry that there's not much room. I'll change that for next year and make a little bit more space for you. All right, so I'm going to take this. I'm going to plug this back into my equation and solve. I could plug it in for either equation. I'm going to choose the top one because that's the most simplest. So 3 equals y plus 4. Okay. And then I'm going to subtract 4 on either side, which gives me, what did I do weird? Plugging that in. Why is that giving me negative 1? Was this supposed to be negative? No, that's not negative. Interesting. Because what I end up with here is negative 1 equals y, which is technically not true. So I'm trying to figure out, but if this was negative, then that would be, I wonder if this is supposed to, I bet this is supposed to be negative. Whoopsies. How about I actually look in the book and yeah, look at that. Okay. Because then when we add 4, nope, that still isn't working out. Oh yeah, it is. Yeah, because this isn't negative. Okay, there we go. Then we get 7, right? Because 4 plus 3 is 7. Okay, and then we can see that this is 7. Perfect. Then those match up. See, I'm finding my own mistakes here. It happens to all of us, guys. All right, flipping it on over. We have a few more. So the next one, it says that we're using the rectangles at the right to answer the following questions. And we need to find the area of the entire rectangle and explain how we figured that out. So if you remember that we can always multiply our sides, right, to get that total length. So I can figure out the entire side, right, by adding our two smaller sides. 6 plus 4, we know, is 10. So I'm going to just write over here just so I keep track of my work. Oops, not 6 plus 10. 6 plus 4 equals 10. And then this side right here, right, when we add 12 plus 5 equals 17. And then we can go ahead and multiply because that's how we would find our area. 10 times 17 equals 170. And we would just say units squared for our area. That would be the area. Now, if we were going to try and figure out the perimeter, right, we know that this side is 10, so this side also would have to be 10. And then our bottom side would also have to be 17 because these lines match up. So I can just say 10 plus 10 plus 17 plus 17. When I add those all up, I'm getting 54 units. Okay. Make sure that you're showing all of your work, not just writing down my answers, because that will not help you on the homework check. Okay, moving on. Number 21, we are evaluating the expression for when A equals 2/3, if possible. And it's not always going to be possible. I'll show you what I mean. Okay, so for this one, we are multiplying, right? 24 times A means that we're doing 24 times, what was A? 2/3. Remember that any number can be put, a 1 can be put over it, and then we can go ahead and do our multiplying. So when we do our multiplying here, right, we can multiply across and then divide. I'm getting 16. Here we're doing 3 times 2/3. Remember, again, I'm putting that 1 underneath it. I can then multiply. And essentially what I'm doing when I say I'm multiplying, I'm doing 2 times 6, or 2 times 3, right, is 6. And then 3 times 1 is 3. I guess I didn't explain that up here. I'm multiplying 24 times 2. I'm getting 48, and then I'm dividing it by 3, and I'm getting 16. Okay, so when I simplify that, then that is 2. I should make sure that we all know what the actual math behind it is. All right, when I get to this, a over 0, I cannot divide 0 into anything, right? So we call that undefined when we can't do that. I'm just going to abbreviate und, not for underwear, just undefined. Okay, now for this one, 0, right, any number divided into that is going to always equal 0. So that would be the answer if we were asked to evaluate. All right, we have one last one on the back. All right, so number 72, the school library has 6,500 titles, books, in its collection of magazines, books, reference materials. The librarian is presenting information at the library to a parent association, and she made the graph at the right. So she made this pie chart for us. According to the graph, what percent of the collection are nonfiction books? Well, again, just like maybe you remember, was it this one or the previous one where we had to figure out of 100% a missing amount? We have to do the same thing. We're going to figure out how much it is for all of this, right? And then we can subtract from that 100. So we're going to take our magazines at 100. I'm just going to do this off to the side. So 10 plus 20 plus 45 plus 7 is essentially the math that I'm doing to add up all of that, right? So this would be 12. So 4, 50, 70, 80. So we have 82% that's already spoken for, right? That's not this. Then I can take 100 and subtract it from 82, right? And then we would get an 8 there and a 1 here for 18. Yep. So that means that this nonfiction piece represents 18% of the total amount of materials that she has. Okay, then for the next question. Could the librarian have preserved this information presented this information in a histogram? Why or why not? A histogram is not going to show us all of this information, so not numerically anyways. So we're going to say probably not. No. Let's see, the data is not numerical. Like, we don't know how many of each one. But she could have used, you know what she could have used? She could have used a bar graph. Oops, could use a bar graph, right? Remember the ones with like the bars, either they're like up and down or side to side? Yeah, that could have worked. So then the last part says how many books in the library are fiction. So if we are told, let's see, are we told? Yeah, we're told up here that there are 6,500 titles, right? And we know that 18 of them, or 18% of them, are nonfiction. So we could set this up like 18% of the 100 are nonfiction. And then we're saying, like, how many books is that? Well, I know that there's a total of 6,500, and I want to know, like, how many that is, right? So then we can cross multiply. You can use a different method if you're more familiar with it. But essentially on my calculator right now, I'm punching in 6,500 times 18 and then dividing by that 100. And when I do that, I have 2,925 fiction books. Fiction books. All right. Hopefully that makes sense. Thank you guys for hanging in there and watching. Come back tomorrow.